Hi everybody. So here we've got a fantastic question involving the area of triangles and proof. We've been given this triangle ABC and we've got these angles here are equal. We need to prove that AB over BD is equal to AC over DC. So with questions like this, often the most difficult thing is knowing where to get started. So what I encourage you to do is to split this up into two separate triangles. You can see we've got triangle ABD, which I'm highlighting in blue, and we've got another triangle ADC, which I'm highlighting in green. Now, if you want to try this question yourself, think about the different ways in which we could find the area of each of these triangles. We know we can find the area of a triangle using a formula 1/2 of AB sine C, and we can also find the area of a triangle as 1/2 of a base times height. So think about how you can apply each of these formulae to finding the areas for each of these triangles. You can pause the video, and when you come back, you can check you're working with mine. Okay, so welcome back if you had a go. So if we begin with the triangle ABD, using this formula, we can identify the sides as AB and AD with the angle between them x. So I'll label this on the diagram. We've got AB and AD. So this will be 1/2 of the length AB multiplied by the length AD times the sine of the angle between them, which we're told is the sine of x. Now we can compare this to the other formula, the other method for finding the area of the same triangle. This time where the base would be the length B to D. So I'll include this on the diagram as well. So this will be 1/2 of the base times the perpendicular height. Now the perpendicular height would be from A to the base of a triangle. So I'll label that with H. And this is useful because you can see that the perpendicular height is the same for both the blue and the green triangle. So that will help us later on. So we'll have 1/2 of the base times the perpendicular height. Now these formulae give us the area for the same triangle. So this means that they must both be equal. So 1/2 AB AD sine x will be equal to 1/2 of BDH. All I'm saying is this area is equal to this area. And what this allows us to do, we can cancel out the halves. So the perpendicular height must be AB times AD times the sine of x divided by this length BD. So what we'll do then is we'll apply exactly the same idea to this green triangle, and then we'll set the two perpendicular heights equal to each other. And hopefully that will give us what we want to show here. So if you didn't manage to do this bit yourself, do you want to try and do it with this green triangle? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So area ADC, using this rule, we can identify the lengths as A to D, A to C. So we'll have 1/2 of AD multiplied by AC multiplied by the sine of the angle between them. And then using half a base times height, this will have 1/2 of a base, which is DC, from there to there, times the perpendicular height. And now we know that these two are equal to each other. So we'll have 1/2 of AD, AC, sine x will be equal to 1/2 DCH. Again, we'll cancel out the halves, and we'll divide both sides by the DC, so we'll get H is equal to AD, AC, times the sine of the angle X divided by the length DC, which is this one here. Now we know the perpendicular height is the same for both triangles, so this equation must be equal to this one. So if I copy this, and set it equal to this one, then can you see what we can do next? We can cancel out the sine x's from both sides, and we can divide both sides by AD, so these will cancel, and what we're left with is AB over BD will equal AC over DC. And that's exactly what we were asked to show here. How did you get on with that? What a fantastic question. If you want more questions on non-right angled triangles, you can download the lessons and the worksheets from my website, mrmathematics.com. I'll leave a link in the description below.